One thing to keep in mind whenever evaluating claims, especially scientific claims, is to think of how much we can expect to know with our current technology. Several years ago on YouTube, I saw someone make the following claim, quote, "There are millions of life forms on Earth, but there is not a single life form observed anywhere in the known universe, and we can see pretty much billions and trillions of stars." So he said that we should be able to find life elsewhere just by looking through telescopes. And since we couldn't see it, it must not be there. I mentioned that with our current technology, we shouldn't expect to see actual life forms with the resolution and techniques available to us at the time. Now the technology is getting better and better. Since then, we've gained the ability to detect Earth-like planets that may have liquid water. But even in the best case scenario, we wouldn't be able to see the actual life forms through any telescope that'll be available to us in the foreseeable future. To detect life would require a spectrographic examination, or if they're intelligent life, we could pick up their radio signals. But as far as visually resolving individual life forms, we wouldn't be able to do it by sight. To make the point, I showed this picture of our solar system, taken by the Voyager 1 space probe on Valentine's Day 1990 as it went out into interstellar space. Aliens looking at this view of our solar system would have no way of telling which, if any, of the planets in our system harbored life. I then showed this famous picture of Earth and said that even this view, with far greater resolution than we can see any extrasolar planet, and showed that you still can't resolve individual life forms. Several people complained that the green of the Earth is confirmation of plant life. As one of them said, quote, "Except of course for this green patches, which is due to chlorophyll of plants. Those are alive, aren't they? But are these green patches really evidence of life? If you were an alien, and you were looking at Earth for the first time and saw those green areas, would life be the first thing you think of? Would you consider it to be a definitive sign of life? First of all, you would have to work to eliminate all of the other possibilities. For example, copper deposits mixed with other minerals such as gold or sulfur or thorium could well produce this color as well. For another example, when you look at green marble, do you think it must have at one point been alive? Of course not. Green does not necessarily mean chlorophyll. But even if you were to rule out all of the other possibilities, if you were an alien, what would lead you to believe that it even could be life? The assumption people seem to be making is that since chlorophyll is green on Earth and it's used by plants, it would be used by plants elsewhere as well. This is an assumption that just isn't called for by the evidence. Chlorophyll is just one of a class of chemicals called chlorins. A chlorin, not to be confused with chlorine, is photosensitive, capable of converting light into energy, and this is exactly why plants use them for photosynthesis. Chlorophyll is a chlorine with a magnesium atom at its base, but it's just one of many pigments that chlorine can produce. Chlorophyll itself comes in several different types, each with their own spectrographic signatures. Here is a graph comparing chlorophyll A and chlorophyll B. Notice they absorb different parts of the red and blue spectra. In fact, there are bacteria that use other chlorins. Rhodospirillum rubrum, for example, is a bacteria that uses bacteriochlorin A, which absorbs light in the 800 to 925 nanometer range, giving it a reddish-purple color. What if it had been this chlorin, and not chlorophyll, that had been used by cyanobacteria, and therefore the chloroplasts in plants? Then we'd be seeing big purple patches, and then these guys would be saying that that purple color means plant life. The fact that the chlorines used by plants on Earth make the plants appear green has more to do with the evolution in Earth's environment than anything inherent in nature. The light we receive from our sun is more plentiful in the red area of the spectrum, but as wavelength decreases into the blue range, the light gets more energetic. This means that plants can get more energy out of these wavelengths, even with less light emitted. So for getting energy from our sun, it's better to have chlorophyll than bacteriochlorin, since chlorophyll can absorb the more energetic blue wavelengths. But the green range in between doesn't quite cut it. It's not as plentiful as red light, but not as energetic as blue light. The costs to the plant of producing a pigment capable of absorbing this light would not be worth the comparatively meager amount of energy it gets from absorbing green light. So the red and blue absorbing chlorines get selected for, green light gets reflected, and plants, as a result, appear green. But what if this were a planet around another kind of star? If it were around a blue supergiant such as Rigel, then it would be receiving very bright light across the spectrum, but especially in the blue range, which again is more energetic than light of longer wavelengths. They would get so much light out of the blue range that there wouldn't be any point in paying the evolutionary costs to produce a pigment to absorb any other wavelength, and so, most likely, plants living on planets around such a star might be red or orange instead of green. Conversely, a red supergiant like Betelgeuse would be so plentiful in the red spectrum that there may not be any evolutionary pressure to create pigments to absorb the blue light, so plants in this case might appear blue. Now consider the case of a very dim star, such as a red dwarf. Life around a red dwarf may be so hard that, if plants can exist at all, they would need to do so by greedily harvesting every single photon they can, which would give any plant capable of absorbing a new part of the spectrum an evolutionary advantage. Plants around red dwarfs may well appear black as a result. So getting back to our original premise, if you were from a planet other than Earth, what reason would you have for concluding that there is life on Earth just by looking through a telescope powerful enough to resolve this image? The answer? None at all. It's one more way that science shows us how the universe is far more complex and far more magnificent than more primitive thinking allows for.